much. Good morning, good afternoon, everyone. My name is Chris Reese, one of the subject matter experts at Award Solutions. And let me just spend a second talking a little bit about my background. I've been in the telecom industry for about 19 years. And in that time, I've worked for an equipment manufacturer for about 9 of those years, and for the last 10 years I've been an instructor at Award Solutions. My area of expertise has been in the wireless space. My entire career has been in the wireless space, and so my focus has been within LTE, UMTS, GSM, GPRS, Edge, AMPS, a little bit of CDMA, as well as a little bit of VoIP, IMS type technologies. Thank you very much for the opportunity to come and discuss this. LTE is a very fun topic to discuss. It is a very exciting topic in the industry, and so I look forward to this opportunity. We're going to get started with the material, and what I'm going to do is I'm going to go through these slides, but as I go through the slides, as questions come up or other things come up that are of importance that I need to draw, I'm going to go to that other application, which is a journal file, to answer those questions. So you may see a little bit of a delay as I go back and forth between those two applications, but I want to be able to answer these questions as best I can. So you have a little bit of information about me. What I'd like to do now is to get a little bit of information about you. So if you would please, a poll has just come up. If you could check what your current role is, I would appreciate it. Just have a little bit of an idea of the backgrounds of everybody, and we'll just spend a minute or two at most. Now, one of the things that's going to happen over the course of this morning or this afternoon, depending on which part of the world you're in, is I will do a number of these types of polls to kind of get an assessment of where we are. Some of them are going to be kind of general polls like this one. Others will be more based off of the content of the material that we are covering. So it looks like a lion's share of our participants are in the customer support space. Number of system engineers, system integration, system test, a couple architects, hardware, software design, research. So good mix, good mix. Excellent. My second question, on a scale from 1 to 3, how much detail are you looking for? 1, be gentle, really looking at things more from a conceptual basis. 2, really, it's not just the concepts, but we also want to talk about some of the key details that are important with respect to LTE. And then lastly, bring it on, more details are better, bits and bytes are good. So again, I'll give you a minute or two to kind of answer that. And I kind of sense a trend already. We're probably about 3/4 of everybody has answered, and a lion's share is concepts and some details, and a few people are bring it on, which is a good level. We can kind of straddle those two pretty easily. Okay, fantastic, fantastic. As Brenda said when we started, if you do have a question, please do add that or type it into the Q&A box on the lower right-hand side, or I guess you'll have to click on a link, click on a button to get to the Q&A box. But when you type in that, it does pop up on my screen, and I can answer that. Sometimes I'll answer it just right that second. Sometimes it will be, a minute or two later as I kind of find a good spot to intermix that. As well as if you just have a comment or just have something you want to contribute to the discussion, please feel free to jump on the Q&A. If you do have a question and you do start with the Q&A, it may end up easier for you to unmute your bridge and then come on to answer the question. right, fantastic. Well, let's go ahead and take a look at what we want to talk about today. There's a few things that we're going to talk about. We're going to start with just a review of the major nodes in the EPC, the Evolved Packet Core. And we're going to look at their functions, and we're going to look at their role in the world. We're going to look at an overview of signaling and user plane protocols, just to kind of get a feel for what protocols are being used. And as a compare and contrast, I will be using UMTS as kind of my background, my backdrop, so to speak, because LTE was designed by the same people who designed the UMTS standard. So therefore, you can see UMTS's fingerprints across LTE quite a bit, especially within the core. We're going to look at some of the steps of one of our more important procedures, which is an attach. How does the mobile let the network know that he's alive, he's ready to do something, and he wants to just kind of get this data stuff going? We're going to look at some of the key ideas behind bearer management, and we're going to look at the difference between default and dedicated bearers, as well as between a couple of flavors of a protocol called the GPRS tunneling protocol. Now, from my opinion, if there is only one thing that you walk away with from today, it is this difference between a default and a dedicated bearer. It is a critically important concept for all aspects of LTE, and it is foundational for the rest of the series. And so if you are not really clear about the difference between a default and a dedicated bearer after we have this discussion in a little bit, please do jump on the bridge, get into the Q&A, and let's nail that down, because that is critically important for walking forward. So that's my plans for the day. Kind of an overview of the whole technology, LTE technology Phase 2 series is we are going to walk through a number of different topics. Tomorrow we'll talk more about policy and charging control, a little bit on voice in sessions 3 and 4. Session 5 and 6 are interworking. 7 is time division LTE. 8 is self-optimizing networks, and 9 is LTE advanced. So the first half of it or so is going to be really focusing on the core and how the core works and plays well with other technologies. And then the last portion is going to focus more on some of the aspects of the radio network. So with our introductions and our overviews taken care of, let's go ahead and jump into our first topic, which is looking at the EPC nodes. So here is a simple diagram of our Evolved Packet Core. Now, for sake of definition, let's define 3 terms real quick. The first term is this Evolved Packet Core, and this is really our core network. It is a packet-only network, and we do not have anything like a circuit switch network in LTE. The assumption is basically this. Data is just bits that we're carrying across a network. Well, voice is digitized. It's basically bits that we're carrying across a network. So idealistically, if I'm dealing with a voice network, really it's a VoIP network that's running over our same packet core. That's our ideal. Not quite there yet. Our second network that I want to just show briefly, and we're not going to talk about it today, is this evolved Universal Terrestrial Radio Access Network, or just simply our RAN. Our EU-TRAN is the radio network that's managing all the stuff with respect to the radio waves. So we can take our network and we're dividing it into the radio chunk as well as the core chunk. Now, let's divide this one more time, or not divide it, let's give one more definition And this definition really goes from the mobile out to the edge of the network, out really to this P gateway, and it's referred to as an evolved packet system, or EPS. Now, the only reason I care about this term EPS, because we've got an EPC already in an EU TRAN, and I don't want to get us caught up in the alphabet soup that is LTE. The point is that this terminology of EPS is a term we're going to see in a lot of our definitions. The key is we're going to look at this thing called an EPS bearer. And an EPS bearer is a data connection that goes from the mobile out here to the core network. So I do see a question asking if I can move closer to the microphone. Hopefully I am getting closer, louder. Let me kind of scooch things around a little bit, and I can that's about as good as I'm going to be able to get right now, and hopefully that will help. Okay, so that's my first definition that I want to make sure that we're clear about, is the evolved packet system, evolved packet core, and the RAN. That being said, as I look at this evolved packet core, there are really 4 nodes that I care about. There are 4 nodes that I want you to really focus on, and that are these 4 nodes here. As a matter of fact, I refer to those as the big 4. One of my little tricks to help me keep track of different things and remember different things. And what we're going to look at over the course of the next few slides is we're going to unpack these 4 as well as a couple of other optional nodes. But for any network that's up and running, for any network that's saying they're supporting LTE, be it the current Verizon network, the current Metro PCS network, the current Telia Sonora network, they will have at a minimum these 4 nodes that I've circled. Others are optional. The first node we're going to look at is a node called the MME, which is the Mobility Management Entity. And as the name implies, it is the entity that manages mobility. And I don't really like that term personally, the MME, because when we think of mobility management, we really think of paging a mobile, keeping track of their location. Even on a stretch, we can think of it as authenticating a mobile. But what we don't really think about with the term mobility management is the setting up and tearing down of these bearers, these data sessions. And so this mobility management manages the data session setup and tear down as well. And when I talk about managing the data session, the bearer setup and tear down, I do mean authentication and authorization. We'll talk a little bit more about those functions in a bit. Got a question on the chat. Shrinu is asking, does the P gateway and S gateway combined into one element for practical purposes? Yes, we will see that in a second. P gateways and S gateways can be combined into single nodes, and I have heard of examples where they are being combined into single nodes. So MME we'll start with. MME's Mobility Management Entity does these things that are on the screen. One more thing I want to add to this. If you come from a background of UMTS or you come from a background of 1X EVDO, the closest node that we're going to have to that is going to be, in UMTS, it's going to be an SGSN. In 1X EVDO, it's going to be a PDSN, so a serving GPRS support node or a packet data serving node. Now, we're going to take this a little bit deeper. Really, this is going to be the call processing engine of these two nodes. That's really the equivalent of this MME. If you go back and you look at one of the advancements that happened as part of 3G, where my MSC was split into a MSC server that did the call processing part and the media gateway, which did really more of the voice processing part, the transport part, the user data part. We have a similar analogy here. You could think of this MME as kind of like being an SGSN server. That's the best analogy that I've been able to come up with for this. All right, so that is the MME. Now, all of the lines that are coming out of this MME are interfaces to other nodes. And there's a couple of interfaces that are very, very important that I want to highlight. The three that I care the most about is going to be this S11 interface, which we're going to see communicates with the S gateway, which we'll talk about in a little bit. Our S1 MME, which is what talks to the E node B, and our S6A, which is what talks to the HSS. This NAS signaling is going to be important too. This is how the MME has a conversation with our mobile device. The others are not quite as important for the day-to-day operation. I'm not saying these other interfaces aren't there, but the ones we're going to focus in on are the four that I have highlighted. So that was the S gateway. The next node that we want to focus in on is, I'm sorry, that was the MME. The next node we want to focus in on is the S gateway. Now the S gateway, his role in life is really this packet data anchor and this local mobility anchor. We really want this S gateway to deal with our packets. So it's really doing a lot of our routing type functions. So going back to our analogy, it's going to be similar to an SGSN and a PDSN. But here is more of the, we'll call it the router piece of that. The piece that takes an IP packet and forwards it to the next node. So again, going back to our analogy of the MSC server and media gateway split of an MSC, we're going to see that this guy is kind of like, for the sake of a better term, I'll call it a data gateway. Really much more of a router concept. The reason that it has as a descriptor a local mobility anchor is because the local piece is saying we want this guy to be fairly close to the E node Bs. We want this S gateway to be in the same city, the same region, same market as our E node Bs, so that when a mobile moves from E node B to E node B, then what will happen is we will tear down this S1 interface to the E node B and reconnect it to the new E node B. So that's kind of the local mobility anchor piece. Some of the key interfaces that we have out of the S gateway are going to be the S1U interface, something called an S5 or S8 interface, which we'll talk a little bit about, as well as that S interface that we've already opened up. If we're dealing with some of our interoperability with other technologies, be it UMTS or even to some degree in EVDO, then we'll see other interfaces that will be involved. But the three that I have highlighted are the biggest three. S-Gateway is a simpler node. It really is designed to be a more, as I've said, much more of a routing type node. Now, one of the things I use with respect to terminology is I will call this a S-Gateway. I know some people will refer to this as an SGW. I'll call it an S-Gateway. And the reason I call it an S-Gateway versus an SGW is I'm trying to distinguish it some way verbally from other nodes that have a similar acronym. So, for example, there is a SGW that is a security gateway. There is an SGW that is a signaling gateway. Now, in both of those SGWs, they don't have the hyphen in the middle. And so by saying S-Gateway, it's at least in my mind the way of distinguishing it from those other nodes, kind of implicitly stating the hyphen, so to speak. And so that's the reason I use the term that I use. You're free to use whichever term you'd like. S-Gateway or SGW is fine. So that is our S-Gateway. The S-Gateway and the MME together are going to have a similar role as an SGSN or a PDSN. Our third node is a node called the P-Gateway. And this P-Gateway, if I go back to my analogy of other technologies, my P-Gateway is kind of like a GGSN, a Gateway GPRS support node in UMTS, and as well as it's kind of like a home agent in 1X EVDO. And its most important characteristic is it is an IP anchor. It is the node that we want to kind of own our IP address that we've allocated to the mobile, so that no matter where the mobile goes, no matter which eNode B the mobile is in, which S-Gateway the mobile is in, even to some degree which radio access technology the mobile is in, we will still have our same IP address. Now it also does packet filtering and something called DSCP marking, diff served code point marking, and really those two things together are focusing on quality of service. So it manages quality of service, as does the data rate enforcement comment. It also deals with billing. Or charging. So its function in life is really to be that gateway to the outside world, that mediator from the point of view of quality of service, that IP anchor. Those are good descriptive terms of this P gateway. Now let's go back and let's discuss Srinu's question for a second. His question was simply this: does the P gateway and S gateway does it combine into a single element for practical purposes? And the answer to that question is yes, it does. It can. I shouldn't say it does. It can. There are some equipment manufacturers that are looking at having an S-Gateway, P-Gateway combined node, right, in the same box. And so really what that means is it means I've got both of those functionalities. I'm not getting rid of the functionalities. But what will happen is I will end up having this interface here, this S5 or S8 interface. Actually, I should say specifically the S5 piece of it will be kind of in skin, so to speak. You can think of it as being a backplane or a procedure call or something else equally simplistic internal to this combo S-Gateway, P-Gateway. and that's the P gateway. So we've talked about 3 of our nodes so far. We've talked about a MME and an S gateway. We've talked about a P gateway. And now our 4th node that we want to look at is a node that's called a home subscriber server. And the home subscriber server is really nothing more than a modern HLR. So from a UMTS perspective, we would call it an HLR. From a 1X EVDO perspective, we would refer to this as a AAA server. Conceptually, it's similar to both. Probably implementation-wise, it is closer to the AAA server. It's a real database. That's probably the biggest thing that we need to remember about this HSS is it is a database. It is a subscriber database. And that subscriber database stores all of our information about the subscriber. Identifier, service profile, current location, authentication-related information, and such. So when a mobile is configured, when a subscriber becomes a subscriber of the network, he will have a data entry into the HSS. Now, one of the significant differences between an HSS and an HLR is really this is much more of a database. And so if you were to compare this node to an HLR, to some degree it's a little bit simpler. You see, one of the problems we struggle with an HLR is it really is much more of a call processing node. And if you look at some of the protocols that are being used, there's a lot of initiation by the HLR. HSS is a little bit more of just a database. And so you can imagine an Oracle relational database company writing HSSs, whereas HLRs, it was very difficult for them just because of the nature of the HLR service. Restate the HLR. HLR is the home location register. Is that what you're getting at, Mike? And it is the subscriber database of UMTS and GSM GPRS for that matter. And the HSS is the new term basically for the same concept. Okay, good. When you do ask a question on the Q&A, if I do answer it, if you could do me a favor and delete the question, that way I know that you got it and I don't need to keep answering it, especially if it's something that you understand. I don't need to keep going. Okay, so those are our big 4. MME, P gateways, S gateways, HSSs. Every network in the world will have at least those. But as was mentioned earlier, that doesn't necessarily mean that is 4 separate physical nodes that an operator is deploying. It doesn't necessarily mean that it is 4 separate boxes. It could be that all 4 of those conceivably are in the same node. I don't really believe that. My experience so far is that we see our P gateway and S gateway really being a single node. Sometimes I'll kind of draw it this way to kind of represent the MME looping in and being a part of it. And HSSs are always separate, always separate. Kenneth has a great question. On the previous page, probably this page here, there is a reference to something called non-3GPP IP. What is that referring to? And actually, we've seen that kind of pop up in a couple of ways. A very, very good question. And I'm going to jump over to this other application for a second to answer it. The UMTS standards bodies are kind of funny. The 3GPP is, if you're not aware, the standards body that created UMTS and LTE. And so what they've decided to do from the point of view of interworking is they say, well, there's 2 flavors of interworking. We have 3GPP interworking, And this really is interworking with UMTS or GSM, GPRS, and Edge. And one of the reasons that that's kind of highlighted is because of the similarity of the signaling. Signaling is similar. Non-3GPP, there are really three technologies that are discussed, or talked about at least, from the non-3GPP perspective. It's going to be 1xEVDO, which is the dominant one that is discussed. There is WiMAX, and there's Wi-Fi. So all of those are kind of clubbed together to represent, quote-unquote, non-3GPP. And another term that you'll see pop up is you'll see these two be referred to as trusted non-3GPP, and this is untrusted non-3GPP. Now, this isn't really trying to be a slam at Wi-Fi. The term untrusted is a technical term, which basically means our interface to the network is either open, like the internet, or closed, like in a leased line perspective. So, for example, when someone like Verizon is doing interworking between their LTE network and their DO network, then that's going to be a trusted non-3GPP interface. If I'm dealing with wanting to deploy Wi-Fi networks and do something similar to femtocells, then that would be an untrusted non-3GPP connection because the internet isn't trustworthy, and therefore we have to go through and do some additional security stuff to make it work. So, Kenneth, does that answer your question? Okay. Basanta, I hope I'm pronouncing your name right. If not, I apologize. Question is, can you cover GTP versus PMIP? Because that did pop up a couple of times in the slides. And it did, and I've got a couple of slides coming up in a couple of minutes that's going to go into a little bit more detail. But let me go ahead and field the question right now, at least on a high level. We have our P gateway, and it will connect to an S gateway. And there's a couple of options for this connection. This is that S5 or S8. Now, and I'll talk about why there's two names for this in a minute. But there's an option of doing GTP, the GPRS tunneling protocol, or there's an option of doing PMIP, proxy mobile IP. Now, the theory is this. Let me give you kind of the theory, and then I'll kind of talk about it from a practical perspective. The theory is if I am a UMTS operator evolving to LTE, as a no-brainer, I will support GTP, because GTP is the protocol we use within UMTS. And so if I am an AT&T, an O2, a T-Mobile, a Vodafone, a Telstra, a Telia Sonora, I'm going to use GTP because I already understand GTP from my UMTS network. If I am a 1xEVDO operator, I don't understand GTP. And so therefore, I want to use something that's closer to what I do understand, and that's where PMIP comes into the picture. PMIP is an evolution. It's not what's deployed currently in our DO networks. In our DO networks, we have something called CMIP, client MIP. We're now doing something called proxy MIP, and they're close enough. So the theory is that Verizon, for example, would do 1xEVDO, an AT&T would do Verizon would do PMIP, and AT&T would do GTP. One more thing we need to look at real quick, though, before we go off too far down that path, is if you look at the connection to that E node B in the radio network, this S1U interface, this is, by definition, GTP only. So in other words, even if I am a Verizon, even if I am an operator that is currently using a DO network, but now moving into the LTE space, by definition, I have to learn what GTP is all about anyway. I don't have an option on this S1U. So what I'm seeing in practice is all operators seem to be going this direction. They seem to be just looking at GTP. Since if that's kind of going in the direction you were going, if you could delete your question, that would be fantastic. Okay, and Kenneth, you responded back saying, yeah, that answers the 3GPP, non-3GPP thing. I do get a kick out of their definition, though, by the way, of 3GPP versus non-3GPP. It's kind of funny to me that they would go and make this big deal out of what this is like, if you're from the same standard as me versus not being of the same standard as me. I don't know. I got a kick out of that. Maybe it's just me. Okay. Are there any other questions at this point that anybody wants to throw out there? Yes, I can kind of hear you. A little bit of an echo, but go ahead. Oh, maybe it wasn't. Okay. If there are no questions, then what I would like to do is I want to do a quick poll, and then we'll discuss the answers to the poll. So Sam is browsing the internet using his using the LTE-EPC network. Which one of the following choices represents the correct choice for carrying his IP packets through the network, based off of what we've looked at with respect to these links and these nodes? Which are the links that are going to carry the packet data to the internet? So we have 50 total attendees. We've got about 25 or so people that have answered, so I'm going to try to see if we can get to about 40 people or so answering questions. I'd really like everybody to jump in and answer what you think is correct. All right, we're about 43, 45. Okay, that's a good number. So if anybody else wants to go ahead and jump in, that would be fantastic. And I've got good news, and this is the best part of these types of polls, is the answer that 53% of the people gave is the correct answer. The packet data will flow from the mobile to the E node B via a radio bearer, E node B to S gateway via the S1U interface, and S gateway to P gateway based off of the S5 interface. Now, some of these other interfaces we will talk about, and like the GX interface and the X2 interface, for example. But the blue answer was the correct one. And as I see people changing their answer from what they had to the blue one, that's perfectly okay. Go for it. Nothing wrong with that. Okay, so that was my network. That was my my overall EPC architecture. There's a couple more nodes we'll talk about kind of as we walk through this in passing, but those were the biggies. Those were the biggies. So what we want to do now is we want to look at signaling and user plane protocols on these network interfaces. And we'll start with just a high-level overview of all of the different interfaces, the major interfaces, not all of them, but the major interfaces that we're going to talk about. So let's start with, instead of going link by link, let's start with some commonality. Let's start with the things that are in common across a good number of the links. And so we got to start with the most important piece of commonality, which is the fact that we're dealing with IP-based transport. You'll notice every link has an IP-based transport. And so this isn't an all-IP network. And depending on which white paper you look at and what have you, you'll see that emphasis on the all-IP portion of it more in some places than others. What do we mean by an all-IP network or an IP network? Nothing more than, this has just got an IP network that are connecting these different nodes, these different devices together. Typically, there's going to be, I shouldn't say typically, logically, there's really two different IP networks. And so just kind of as a compare and contrast, this is probably a little bit more of a realistic drawing. I'll have my eNode Bs, all my eNode Bs out here, and they will all connect to an IP network. And we're just going to stick with IP for a second. We're going to kind of go a layer deeper than IP here before we're done. Off of this IP network, we're going to have our MMEs, and I'm going to kind of draw it this way to represent multiple MMEs. And I've got my S gateways. And again, I could have multiple of those. I'll draw it like that to represent the multiple. And then I'm going to have another IP network out here. So really, that's going to be a more realistic picture in the sense of connectivity, in the sense of network deployment, in the sense of operational management of the network, is we're going to have these probably two different IP networks set up. Now, I've got it drawn as two. It doesn't necessarily need to be two IP networks. It could be just one. So as we start to talk about these interfaces that we have, the easiest way to think about them is kind of how they go through the network that I have on the screen. So for example, as I'm dealing with this S1 MME link, for example, it really is here. Right, so this would be my S1 MME. My S1U interface would be here. And my X2 interface would be this green line that I just drew. So those are going to be those physical connectivity versus what I like to refer to as a logical connectivity. Okay? But we're just talking IP. We're just talking IP. Now, the reason that that's important is we talk about something being a neighbor or an eNode B being configured with information about how to get to a node. What does that really mean? What that really means is for my eNode B to know of another eNode B as a neighbor, then he just has to have the IP address of that neighbor. Nothing more, really. I've got a question, and I may need some more clarity on this. Where is SAM located? Oh, you mean our mobile? Is that what you're talking about, SAM? I'm not sure what you mean by SAM. I think is it INA? If you could give me some clarity on your question, I would greatly appreciate it. Okay, so we've got our IP network. That's the first thing that I want to describe. Oh, SAM is an OANM box. Oh, okay. Thank you, Vicenta. So, really good question. Let me jump back to this other slide for a second and talk about it. There's a number of ways that we could deal with respect to OANM. And I don't know exactly how a given operator is going to deal with OANM. It could be that this SAM box could be located just connecting to these existing IP networks. That's kind of my gut feel, is it could be something like this. Another response, or another thought that I have is it could be something like this, where both of these kind of connect to another IP network, and then it's kind of down here. Those are my thoughts. Where is SAM located? It's an eNode B OANM link is what SAM is, and so in that case, I would kind of, as I've already highlighted, I would say it's kind of this link here or this link here. And if somebody has some more insight into that, that would be fantastic. I'm not sure specifically how that is in your network. Srinu has a question. What if the neighbor IP address is not listed in the eNode B? How is the call routed? Very good question, Srinu. And there's a lot of ways that this could be done, and so I'm not going to delve into the self-optimizing network topic. That is a completely different thing that is not going to be deployed day one. And so where you can have more of neighbor discovery and all that kind of jazz. We're going to kind of leave that one aside for the moment. If a eNode B does not have the IP address of his neighbor, they're not neighbors. If they're not neighbors, they can't talk to each other. If they can't talk to each other, you can't do a handover between the two. That is going to be my stance at this point. And based off of my understanding of the way at least initial deployments are rolled out, eNode Bs will need to be configured with neighbor info. So just like today on your in your AT&T or in your UMTS network, what you have to do is what a craftsperson has to do, what an engineer has to do, is when they're creating a new cell site, they bring that eNode B and then they configure it with neighbors, and then they configure the neighbors. They have these cell relations and all that kind of jazz. That's going to have to be the same way here. What does it mean to configure a neighbor? It's going to look more like the way things are done today for inter-RNC. where we have to say, okay, this is actually a neighbor that's on a different node. We need to have that neighbor's address, specifically IP address, and such. So I guess the simple answer, Shrinu, is what if a neighbor IP address is not listed in the E node B? How is the call routed? It's not. It's not. There are some options of going back up through the SGSN, I'm sorry, the S gateway, going back up to the S gateway, but we're going to leave those aside for a second. Okay. Good discussion. Now, we've talked about the first layer of our networking, which is the IP layer. And I want you to notice something else. There's nothing below IP that's listed on the slide. What we could do, and probably what would be a more realistic thing, is we could go and we could say, well, I have some type of lower layer running over some type of physical layer. So this lower layer could be something like Ethernet or Metro Ethernet or carrier-grade Ethernet, Ethernet backhaul, I'll say Metro E. It could be something like MPLS. And then the physical layer could be something like an OC3. Or it could be something like Sonnet. Not defined in the specification. The only thing that's defined is IP. You would have to work with your customers to define how you wanted to do the lower layers. Okay, so as we kind of build our way up this protocol stack, we've got our lower layers at the bottom, we've got IP, and now we start to see some differentiation. And there's really 2 or 3 branches that kind of go out from how we're going to deal with protocols. The first thing I want you to notice is most of our protocols are actually running over a layer called SCTP, Stream Control Transport Protocol. And what I want you to remember about SCTP is it's basically like TCP, the Transmission Control Protocol, but just jazzed up. It's more reliable. It's more conducive for signaling than TCP. And I got a slide that'll talk about that here in a little bit. UDP is another protocol. It's the User Datagram Protocol. And that is really a protocol that it doesn't do a whole lot. It's really just kind of there because we need something there. The very top is our real application protocols. And what you'll see that we have 1, 2, 3, really 4 dominant protocols that we're going to talk about. This X2AP, this S1AP, GTP, and diameter. So we'll talk about those over the next few slides. One other protocol that I want to mention is something called the non-access stratum, or NAS. This non-access stratum is the protocol between the mobile and the MME. And it's actually carried over the S1 MME interface, carried over these S1 AP messages to get down to the mobile. So those are the 5 major protocols that we want to at least have some awareness of as we move through the network. So let's crack those open. The first one we want to look at is going to be, oh no, before we do that, we've got user plane. From a user plane perspective, we've got really only one that we're going to care about, which is GTP. And so we'll spend a couple of minutes talking about GTP here in a few slides. GTP will be our dominant user plane protocol. And this is our GPRS tunneling protocol. If I'm using PMIP, Then we have a protocol called GRE, the Generic Routing Encapsulation Protocol. So they're kind of hand in hand. If I'm doing the GTP option, we use GTP. If I'm doing the PMIP option, we're using GRE. At this point, let me go ahead and tackle one thing before we get too much farther. I want to show why we have this S5, S8 separation. Why don't we make a decision and just call it one thing? So S5 is the term we're going to use for intra-operator. So in other words, if I am an AT&T and I have my S gateway and I'm having my S gateway talk to my P gateway, then we are technically going to refer to that as an S5 interface. Compare and contrast, S8 is inter-operator. My inter-operator interface. So that would be an example of roaming. So let's just say, for the sake of argument, I am a Verizon subscriber. I have my my Verizon LTE device, and I decide to take a trip to Europe. And I connect to the Vodafone LTE network in Rome, and I'm using my LTE device in Rome. So it would be the Vodafone Rome S gateway connecting to the Verizon USP gateway. And since we're having to go between these operators, we're going to refer to this as the S8 interface. Now, in reality, all that really means, and this is another one of those things where the standards bodies kind of over-define some things for us. S5 really is saying security optional. S8 is really saying security required. And that's it. That's really all that's saying between S5 and S8. If I'm dealing with the S8 interface, I'm crossing between two operators. I've got some type of demarcation line that I'm crossing, and so therefore security needs to be there. It needs to be present. If I'm dealing with intra-operator, you know, it's my network, it's my connections, I trust it, I don't need to do security of any form if I don't want to. So that's really those differentiation there. Okay, so we've got our S5 versus our S8 discussion. So let's start looking at each of the different nodes. Each of the different links. And this first link is an X2 interface. And there's a lot of reasons why an X2 interface exists, but to be completely honest, it really is only here for one reason, at least in the short term, and that is handovers. Inter-eNode B handovers, no more, no less. It uses a protocol called the X2AP protocol. And the X2AP protocol is a new protocol that was defined within LTE that really just communicates things like handover requests, accepting handovers, and those sorts of things. Fairly simplistic. From a user plane perspective, it's just setting up a GTP tunnel. Nothing more, nothing less. Now, what is a GTP tunnel? A GTP tunnel is nothing more than just an internal encapsulation for routing purposes. It is really nothing more than just a way of taking that data that we're really trying to get sent to the mobile and putting it inside of another envelope for the sake of internal routing. So that's the X2AP. Not a lot I want to talk about with respect to that. It's a fairly simplistic link, a fairly simplistic concept. As we kind of move up the network, the next one we want to talk about is something called the S1AP. Now, this S1AP is going to become very, very important, and it has a lot more complexity to it. This is really how the MME and the eNode B communicate to one another. And some of its features is really the establishment and tearing down of the bearers, as well as dealing with things like paging. And so this S1AP interface is really going to be that communication about the service. Do me a favor, go up to the feedback box at the very top. You'll see that it's got different colors. If your background is in UMTS, can you give me a blue color? And if your background is in 1xEVDO, give me a red color, please. But my background is really more predominantly UMTS, so I'll call that one blue. I've got a couple of reds in here. Okay. Now, the reason I want to ask that is because if you've got a UMTS background, then really this protocol is going to look very similar to a protocol we use in UMTS called RANAMP. Not going to be able to do that same level of similarity when we're talking about 1xEVDO. You might say this is similar to the RP interface, maybe. It is from a positional perspective, it is from a conceptual perspective, but it's really not from the perspective of looking at the messages. Kind of a different beast. Okay, good. That's the S1AP interface. My example here is saying one of the functionality would be this ERAB setup. And what this ERAB setup is really all about is setting up resources for a bearer, for a data connection. Okay. We've been going for a little bit, and I want to make sure that we can sneak in a couple of breaks this morning. So what I am going to do is let me just kind of open things up for questions for a second. I know we're kind of in the middle of our signaling discussion, but I would like to open up anything for questions. What I would like to do is I am going to go ahead and I'm going to share a timer, and we're going to take a 10-minute break, and we're going to start back up when our timer started. If you would do me a favor and go up to the feedback button again that we were just playing with before the break, and why don't you give me a feedback of purple, just to let me know that you are here and back and can hear my voice. I would appreciate that. All right, fantastic, fantastic. All right, well, let's go back and turn these to green, just so I can kind of know that if these things change, it means something. We had a question during right before we broke. Shrinu asked a question with respect to What if a neighbor, I'm going to back up to the X2 interface slide because it's related to X2. What if a neighbor IP address is not listed in eNode B? How is the call routed? And I said, well, it really isn't right now because with respect to, I have to have the neighbor defined, and that neighbor definition is really being done by, a human being, not just machines talking to one another. And then he came back with a further question that I wanted to discuss. There must be some default address that the eNode B could route to if the particular IP address is not listed as a neighbor. Is that correct? Srinu, my understanding would be no. What we would see is we would see that, and we've got to kind of take a step back and think about it from the radio network perspective, right? So let's kind of create a scenario a little bit here. So I've got a mobile, and that mobile has started to move away from it's actually connected to this eNode B on the left, and he started to move away. He started to move towards the right to the eNode B on the right. And so now what's happening as that mobile moves through the network is he's going to provide some measurements. And he's going to say, I see this eNode B on the right. Well, really what he's going to use, he's going to use an identifier. He's going to use a characteristic of that eNode B that's referred to as a physical cell ID. And if you come from a UMTS background, it'll be a physical cell ID would be very similar to a scrambling code. If you come from a 1X background, a physical cell ID would be very similar to a PN offset. Now here's where the kicker comes in. If these two eNode Bs are neighbors, if they're defined as neighbors, we'll say that this is eNode B1 and this is eNode B2, inside of eNode B1, there will be a neighbor list. And that neighbor list, call it just NL for short, it'll say eNode B2, it'll say the IP address, and it'll say this physical cell ID, PCI. So in other words, when eNode B1 sees a measurement report, a message from the mobile that says eNode B2 is good, really it's not going to say eNode B2 is good. It's going to say, well, PCI 27 is good. And eNode B1 will say, well, PCI 27 is eNode B2, and that has the IP address of 1.2.3.4 for the sake of simplicity. So to kind of pull things back around to your question, Srini, if I don't have this configuration information here, we got two problems. One, I don't have the IP address of that second eNode B. And two, which is the more important issue really, I don't know who PCI 27 is. So I have no way of equating PCI 27 to IP address 1.2.3.4 or eNode B2. So really we can take a very binary approach today. Once we start looking at some of these self-optimizing networks, this discussion kind of starts to go away a little bit. But for today, it's binary. If they're neighbors, all this stuff is configured. If they're not neighbors, I can't do a handoff to it. Does that help? Okay, I take silence as understanding at this stage of the game. Yes, okay, fantastic. Thank you, Srinu. Okay, so let's kind of get back start again with our discussion. We've talked about the X2 interface, fairly simplistic interface. S1AP, a little bit more complicated. Not a whole lot else I want to talk about with respect to the X2, or the S1 interface, other than just the obvious thing. Right, those of you who are new to LTE, don't you love the acronym names, or the identifiers, the link identifiers? They're so insightful. S1, S2, S11, S what have you. It's like, golly. The key is if it starts with the letter S, except for the X2. X2 is kind of an exception to this rule. If it starts with the letter S, it really is an LTE core interface. And what we'll see is we'll see actually some older interfaces have been kind of jazzed up a little, and they'll add the S to the front of that as well. But the S ends up being important for that regard. A little bit on SCTP. This is the Stream Control Transport Protocol. And there's a lot of stuff we could get into with respect to SCTP. But the thing that I'm most interested in is just a couple of basic things. The first is SCTP, you can think of it as TCP+. Okay, well, that doesn't do me any good if I don't really have a good feel for what TCP does. Well, what TCP does is it does acknowledgments, it does in-order delivery, and it does retransmissions. But one of the negatives of TCP is it's really assuming two endpoints equal to, we'll say, people, for simplicity. What I mean by this is TCP is great for the internet because what it's about is it's about me downloading a web page. So therefore, this TCP stream is really only one stream of information to me, right? So from the web server, which I'm kind of considering one of the two people for the sake of this discussion, and my computer, the other of the two people for the sake of this discussion. Now, that discussion starts to fall apart when we start dealing with signaling networks. So I've got an eNode B, which is one node. I've got an MME, which is another node. But it's very possible that I've got multiple users' data that's flowing at the same time, right? So user 1 is in the process of doing an attach. User 2 is responding to a page message. And user 3 is going idle. So what happens if I lose user 1's message? Well, if it were TCP, it doesn't treat them as three separate streams of information. It actually treats them as one. So in other words, user 1's message being lost over this IP network delays user 2 and 3's messages from being delivered because of the way their acknowledgement scheme works. So that's an important point in my opinion. So what SCTP is all about is saying, well, we're still going to do acknowledgments, we're still going to do retransmissions, we're still going to do in-order delivery, but what we're going to do that's different is we're going to treat these streams of data as independent. So in other words, user 1's data doesn't have any impact on user 2's data. Now, what's really happening with respect to SCTP is it's trying to look something like SS7. It's trying to pretend, or I don't want to use the term pretend, it's trying to, how do I want to say it? It wants to make IP reliable like SS7 is. That's the way we want to phrase it. Now, SCTP is actually a part of a larger initiative within the IP space called SIGTRAN. Signaling translation. And what SIGTRAN is all about is really nothing more than trying to have SS7 run over IP. Now, we're really not doing SS7 in LTE. We're not doing SS7 anymore, but we're still going to take some of the reliability pieces. We're going to take some of the enhancements of SIGTRAN, namely SCTP, and use it. So that's SCTP in a nutshell. If you remember nothing else, it's kind of this TCP plus, jazzed up TCP. The other thing that we have is we have this GTP tunneling. And GTP is GPRS tunneling protocol. Now, as the name implies, GPRS, this is a technology that's been around for a little while. It's actually a flavor of technology that's been around since really the mid-90s. And its sole purpose in life is to do internal routing, as we've already talked about. So what my picture is showing is basically some server in the IP network delivering a packet to the P gateway. Now, the reason that the P gateway is receiving this packet is because the destination IP address is the IP address that we temporarily assigned to the mobile. Well, from an internet perspective, that destination IP address is the P gateway. So the P gateway will receive it. Now, what the P gateway is going to do is he's going to look at that IP address, and he's going to say, okay, I have a tunnel set up for this guy. And since I have a tunnel set up for this guy, what I'm going to do is I'm going to take this payload here as is. I'm going to take this payload as is, and I'm going to then tunnel it, where I'm going to put a GTP header on it, not shown in the slide, a UDP header, and then an IP header. Now, that IP header is really the interesting part. So you'll notice that now my source address is the IP address of the P gateway, and the destination address is the IP address of the serving gateway. The S gateway will receive it. The S gateway is going to strip off these outer headers, take the packet as is, add his own GTP header, his own IP header, which now is the source is the S gateway IP, the destination is the E node B IP, and route it to the mobile, or route it to the E node B. The E node B will then strip off all that junk and forward it to the mobile. If we wanted to show another E node B being involved, so I'll draw a second E node B so that we can see the X2 interface, it's really going to be fairly simple. It's going to be IP and payload. And so now, in this IP header, we've got the source address is going to equal E node B1 IP, and source or destination address will equal E node B2 IP address. This destination E node B2, what he'll do is he'll strip off the payload, strip off the IP, and send it to the mobile. That's tunneling. Why do we do this? Well, two reasons really. One, we don't want to have our IP addresses that we allocate the mobile to be routable within this EPC core. We would want to keep those separate. This is kind of like, why do you keep your private IP address space for your company separate from the internet? Right? We don't want them to route in each other for a number of reasons, privacy, security being one of them potentially. The other reason, which I think is the more important reason, is my eNode Bs can change over time as I move around the network. So we're kind of looking at what I've drawn here is kind of the middle stage of a handover process. Well, what will eventually happen is I'm going to drop these connections and have a connection directly from the S gateway to the eNode B2. Well, what really is changing, what's really going to change is nothing more than this destination address here. It's going to go from being eNode B1 to eNode B2. So GTP is really more of a mobility enabler, a routing enabler, than it is a tunneling protocol. I don't know if that makes sense, but that's kind of where I am with that. Okay, so Anil has a question. What are the key differences between mobility handling via GTP and mobile IP? And that's a very, very good question. GTP versus PMIP, and specifically GRE. The point basically is this. S gateway, I'll draw it a little bit different. We'll do it this way. The first question I have to ask, I'm sorry, the first way I have to answer this question is GTP is actually a creation of 3GPP. PMIP is actually a creation of the Internet Engineering Task Force and 3GPP2. And the reason I mention that is because we do have a little bit of a not invented here scenario. Since 3GPP invented GPRS tunneling protocol, obviously in their eyes, this is the best thing. So that's the thing they're always going to push. Now, it's not a completely fair statement, but there is some of the not invented here stuff that we do have to keep in mind. The other thing that I want to add to this discussion is kind of their history, just for a second, and then I'll draw a couple of pictures to show kind of how this applies to us. GTP was designed from the very beginning to be very, very flexible. It was designed to be very flexible in the sense of handling multiple instances of tunnels per UE, a lot of additional signaling, an integrated signaling approach, whereas MIP was an old IP term, an old IP protocol, that what they decided to do was they decided to kind of, for the sake of a better term, wireless it up. Because the original MIP and PMIP was designed more for nomadic computing. So I have a laptop and I'm going to use mobile IP so that no matter where I'm using my laptop, in my home office, my company's office in my home city, or if I'm going to another city with my same company, I still get my same IP addresses. But then they started to use that for more wireless purposes. For how it relates to us today, the big issue is simply this. For GTP, I can have multiple tunnels per mobile, per UE. Now, why do I want multiple tunnels? I mean, that seems like kind of a squirrely thing on its own. Well, there's a lot of reasons, but the bottom line is the reason I want multiple tunnels is because they can have different qualities of service associated with them. So in other words, I can define one quality of service for each of these different tunnels, and then my S gateway ends up being really nothing more than a GTP cross-connect. It's a fairly simplistic node, trying to simplify that. As I look at this from the perspective of PMIP, I only am allowed a single GRE tunnel per mobile, per UE. What ends up happening on the left-hand side of our S gateway is we still have our multiple GTP tunnel option. So what ends up happening is we end up having some kind of funny things happening where my S gateway gets more complicated, my P gateway kind of has to handle things in a different way, but really this is the bottom line. GRE, one tunnel, GTP, multiple tunnels. If you look at 1xEVDO, they do have ways of kind of sharing this tunnel. That's where those different, what's the term? In 1xEVDO, we have the multiple sub-connections. I can't remember the term of it off the top of my head. But basically, that's kind of what they're doing is they're saying what we're going to do is we're going to share this tunnel with multiple services with different qualities of service, and we'll use some other mechanism to separate them out. So that's kind of the same thing here. So does that help? Of the difference between GRE and PMIP? Other questions about GTP as a concept before we move forward, okay? Rizwan, so GRE does not allow simultaneous sessions to multiple P gateways, where GPRS does. That is correct. Rizwan's question is absolutely correct. We do get a benefit from GTP in the sense I could have multiple P gateways involved for various reasons. When we're dealing with GRE, we don't have that luxury. And so that's one of the things that DO operators, as they move towards LTE, are having to kind of figure out. But Rizwan, they've been able to solve these problems before in DO where they only have a single home agent. You know, as we look at this from LTE's perspective and we look at it from even UMTS's perspective, this multiple GTP tunnel thing is a benefit. But there are other ways we could solve the problem. And that's kind of what DOs haven't been dealing with for the last 10 years. Good question. Okay, so we've talked about GTP from a conceptual standpoint. Let's talk about it now more from a protocol standpoint. Really what we've been talking about is the GTP-U protocol, the user plane. Now, there are various flavors of this, and again, we don't want to turn this too much into a history lesson, but there was a GTP version 0 that has since been killed. It's no longer with us. But what we're going to use is GTP version 1. Now, this GTP version 1U, this is the same for GPRS, UMTS, and LTE. So from a user plane perspective, really nothing has changed. Nothing has really changed. So it's a simple transition. Where things have become a little bit more complicated is going to be from a GTP control plane perspective, right? So the C is control, and now we're dealing with GTP version 2. Version 0 has been killed. It no longer exists. Version 1 is what we use in GPRS and UMTS, and version 2 is what we use in LTE. And so we're going to use version 2. Now, the only reason I'm pointing this out is when you guys get a few more days into the series, you're going to have a conversation about interworking with 3GPP technologies. And that's going to be one of the significant things is as I'm interfacing with my UMTS network, I have to do things different because it only supports V1 of control. Or I have to update my UMTS network to support V2. So that's going to be that's going to be a difference that's going to be laid out. Now, really, if I want to boil this down, what is the real difference between V1 and V2? Well, it's really more of a nomenclature difference. And so, for example, for example, when I'm talking about V1 control, we're dealing in UMTS, GPRS, and the terminology we use for the establishment of a data connection, this is primary and secondary PDP contexts. That's the term we use, primary, secondary PDP context. There is a quality of service model that's used for UMTS and GPRS. That's V1C. V2C is really for LTE, and so the terminology we're going to use is default EPS bearer and dedicated EPS bearer. As well as we have a richer LTE quality of service model. So those are the real differences between the two technologies on a high level. But in reality, all GTP version 2 is about is creating, modifying, and tearing down tunnels. That's its sole purpose in life. Just setting up and tearing down these GTP version 1U tunnels. So that's GTP. Questions about GTP before we move to having a discussion about diameter? Now we're going to look at diameter. Now I want to go in a little bit more detail than what I have on the slides here. Because diameter is a little bit more complicated than a lot of the other things that we've been talking about so far. So far, when I talk about the, I say a protocol is the S1AP, or protocol is the GTP version 2C. What I really mean is there is a protocol that's defined in the specification, and it has everything that you need. It's pretty solid as a standalone protocol. Diameter is a little bit of a different beast. What diameter is really about is you should think more of diameter as a framework. It's a framework. It is a enabler. It is a flexible protocol that I can use in many other ways. And so I'm trying to think of even you could probably as a decent analogy for diameters, you could think of something like HTML maybe, right? HTML may be a decent analogy where HTML is a flexible protocol, a language that I could use for complicated web pages. It could initiate Java. It could initiate other scripts. There is some framework to it. Don't get me wrong. It's structured, but it's flexible. You can think of diameter being in that same vein. Structured, but flexible. Now, what we're going to see with diameter, and this is where LTE comes into the picture, is they're going to say, well, diameter is this framework, and what we're going to do is we're going to define a specific use. And so one of those uses, as in the example here, is an interface, the S6A, that is the MME HSS interface. Now, that MME HSS interface is really used for the MME to query this database. Update location, download information, those sorts of things. And so that's going to be the use of diameter. Now, that use is really defined within the LTE specifications around a series of attributes. So, for example, I'll have a message, update location request, which I'll have an abbreviation of ULR, and that ULR is going to have something called attribute value pairs, or AVPs. Think of these AVPs as the acceptable parameters. The acceptable parameters in the messaging that's allowed for this interface. So you don't just have to look at that it's diameter and go to the diameter specification in the Internet Engineering Task Force website. You can't just look at the 3GPP definition of this interface. You have to actually use both. And so there is a specification called the S6A, and it will define these attribute value pairs. By that same token, if we look at the next slide, I've got a interface called the GX interface, which is really used for some forms of quality of service. And it's going to interconnect to a node that's referred to as the PCRF, a policy and charging rule function. Well, basically what the GX interface is all about is it's not trying to deal with subscriber information and location and authorization and authentication and quality of service, except, subscriptions and all that kind of jazz. What the GX interface is really only dealing with is an exchange of quality of service rules. And you're going to have a session focused in on the policy and charging control, where this GX interface is going to end up being the linchpin in the whole system. But for right now, what I want you to see is, I want you to see that I've got still the same diameter structure, the same diameter messaging, but what I have is a completely different use and a completely different set of these attribute value pairs. So unlike our other interfaces, when I make the statement S1AP, GTP, V2C, that actually means something solid. When I say diameter, we have to say, okay, wait a minute, diameter and what? Where is that thing that's going to describe the use of diameter? Questions about diameter? I won't even use my joke that the diameter protocol is twice as good as radius. Okay, good. So to authenticate a subscriber and deliver requested quality of service, LTE uses diameter protocol on the following interfaces. So which interfaces are diameter interfaces? I've got a question from William. Can you give an example of how a diameter is used? Yeah, I can. Let me finish this poll, which I think pretty much everybody's going to, get, the same thing. We have, almost everybody doing S6A and GX, and that would be what we would like to call the correct answer. Okay, I think we've got quite a few people who've answered at this point. Let me jump over to my whiteboard and answer William's question. And actually, William, my diameter joke, sake of a better term, it wasn't really funny, so I don't know that I want to call it a joke. Diameter is actually an extension of a protocol called radius, which was a protocol that was originally developed for the sake of dial-up modems. And it was really trying to be a very flexible protocol so that we could query a database, no matter which modem the subscriber showed up on, to get authentication information, authorization information, extend it, restrict people. If somebody is, say you did dial-up modems to dial into your corporate network, and somebody leaves the company, well, obviously we want them to no longer have access anymore, so we want to remove them and all that kind of jazz. So diameter is really a very flexible protocol that's in that same vein as radius. Now, the term, if you come from a DO background, where you're going to see both radius and diameter pop up is in a node that's referred to as AAA, and that's really kind of a good thing to think about for a second, because it kind of helps us understand what this this protocol is trying to facilitate for us. What AAA stands for is authentication, authorization, and accounting. We've talked really about the first two to some degree. We haven't talked about the last one as of yet. We'll talk about that here in a second. So what's going to happen is when my node, and we'll say the MME for the sake of example, goes to query the HSS, this is going to be an example of an update location request. And if we were to crack open that update location request, there's a number of parameters that we would expect to see. And let's talk about those a little bit. Those could be things like the MZ of the mobile, the MME ID, any type of characteristics. Those are probably the best ones that I can come up with. I'm going to make this a little bit smaller. So that would be the update location request. When the HSS goes to respond, it's going to do an update location answer. Now, the name of these messages also kind of helps us, the last letter at least. Everything is a request answer. The HSS is not an initiator, really. He's more of a request answer type of a node. So he's answers, and if I look at the contents of this answer message, it's going to have things like what are the networks subscribed? It's going to have some type of potentially billing-related information. It's going to have quality of service-related information. It's going to have, oh, I don't know, what have you. If I'm dealing with something, my IRAT characteristics, something like that. How am I dealing with things like SMS and so on? So really subscriber database stuff. Now, that is the way this is going to look if I'm dealing with going to an HSS, which is that subscriber database. If I take the same discussion and now I say, well, I'm going to deal with diameter, but I'm going to look at it from how it's processed on the GX interface. Right, this was the S6A. Now I'm going to look at it from the GX interface, which is going to be a P gateway going to this policy and charging rule function. And so I'll have a message that's called a CCR, a credit charge request, and I'm going to have a CCA, a credit charge answer. And if I look at the contents, it's going to include things like, so CCR is going to be MZ, network that we're trying to connect to, quality of service that's been requested, and so on. The CCA is going to include things like the quality of service rules that we're expecting the P gateway to follow, billing related information, and so on. And I could take the same discussion and I could go and I could look at another interface, which is a billing related node, and I would see, well, what I'm going to send on that interface, right? So other diameter. I could use this to send billing records. I could use this to request IP addresses. And so on. I mean, there's the countless options. And so, William, that's kind of what I mean with respect to an example or how diameter is going to be used. It's a very flexible protocol. Now, what's going to actually happen, one more layer of detail and then we'll move on. What's going to actually happen is there is, and I'll kind of shove it in here for the sake of a better place, there's an application identifier. So in other words, if you were to look at a diameter message, it would actually include, oh, this is for the GX interface, so follow the GX rules. Oh, this is for the S6A interface, follow the S6A rules, and so on. Vicente is asking a question. Unlike HSS, The PCRF can initiate messages. That is correct. That is correct. The PCRF can actually send a message to the P gateway, and it's called a reauthentication request or an RAR. And not to take too much away from the discussion on PCC, policy and charging control, we will get into this stuff in a little bit more detail. But this PCRF ends up being that quality of service rule node. But yeah, it can initiate as well. Okay. William and Vicenta, if you could delete your question if I've answered it, and if I haven't answered it, if you could give me a little bit more clarity of what you want me to talk about, I would appreciate that. And yeah, the answer to the poll is S6A and GX. That's what we were getting at with respect to diameter. That should be pretty obvious at this point, since we spent the last few minutes talking about diameter. Excellent. Okay, we've talked about two things so far. We've talked about the nodes in general. I want to focus in on the big four. MMEs, S gateways, P gateways, HSSs. Now what we're going to do is we're going to look at a concept, a signaling event called an attach. Now before I open up what an attach is, oh, I'm sorry, I've got a question. What happens when you delete the subscriber from the HSS? How does the HSS inform the MME? Yeah, I'm kind of oversimplifying this a little bit. Vipul, I hope I'm pronouncing your name right. The HSS, for the sake of operational events, can delete people, can initiate informing people. But the point I want to kind of stress is the HLR was much more of a thinking entity. The HSS is really more of a database concept, and diameter kind of helps facilitate that. So you're right. I am oversimplifying what I'm describing here, but that's only from the purpose of trying to do that compare and contrast. Does that make sense? Okay, cool. I want to describe the attach conceptually before we get into the signaling events. Now, if you come from a GSM, GPRS, UMTS tradition, for the sake of a better term, then the attach you're familiar with. This is really how the UE lets the network know it is on. If I wanted to compare and contrast this to what I would see from a 1X or 1X EVDO perspective, we would refer to this event as a power on registration. Now, we've got a little bit of a different scenario now. When we were dealing with UMTS, GSM, we really had a scenario where the mobile was always reachable due to a permanent identifier. And that permanent identifier we would refer to as the phone number. So in other words, it made sense for me to be attached but not actively doing a packet data thing, because I always had the circuit switch network to rely on. Now it's a little bit of a different story. Now, within LTE, and again, we're going to ignore all of these other scenarios like circuit switch fallback or any of these other things where I might use 3G's voice network. We're just going to focus in on, for the sake of this discussion, plain vanilla LTE. If I am attached but don't have a data service activated, does my phone do anything of any value? And the answer to that question would be no. My phone does not have any value to be connected to the network unless it actually has a data session established at the same time. So what we're going to see is change from what we've seen in 3G to what we're going to look at here in LTE is we're going to see that the EPS attach actually includes a default bearer establishment. A singular default bearer establishment. Not EST, that's fine. There we go, establishment. A little bit of a different thing than what we've dealt with in the past. Now, before I go through, well, let me go ahead and show the kind of the high-level process of this, and then I want to have a discussion of default versus dedicated, because that, as I said when we started this discussion today, that's my most critical concept I want to make sure that we communicate. We're going to use this for the sake of example, mobile powering up. So I've got one of these new LTE smartphones. I go to the airport. I get on the airplane. I turn my phone off. After I turn the plane lands, I turn my phone on. What does the phone do? Step 0. The mobile is going to go through scanning, looking for frequencies, reading broadcast channels, making sure that this is the network for the operator that I've subscribed to. Establishing a signaling connection. That's all this is the establishment of a signaling connection. After that, the mobile is going to send up an attach request. We're going to authenticate. We're going to select the appropriate S gateway and P gateway, and then we're going to establish a default bearer and assign an IP address. So there's that default bearer concept popping up again. But what I want you to see is the attach procedure includes the default bearer establishment. So what is a default bearer versus a dedicated bearer? Well, a default bearer is going to be the first bearer to a network. And a PDN is nothing more than just a packet data network. It's the first bearer to a network. Another term we could use, as shown in the slide, is it's the first bearer to an APN, an access point name. Now, all an APN is a name of an external network. It's just the name of an external network. As part of that default bearer address, that default bearer connection, we're going to be assigned an IP address. So IP address assignment happens when we establish this default bearer. Now, in my example, I am connecting to two different APNs, two different access point names, two different packet data networks. An example of that might be Internet and IMS. It could also be Internet and a corporate network. Internet and some type of other internal private network that an operator would support. Now, here comes the kicker. This is where we need to have these differences in bearer names. Let's say we need to support some type of service. Let's say that we need to support, for example, a VoIP call. Well, my default bearer is really going to be based off of a nominal data rate. It's not really going to be used to maintain high qualities of service. If I need to have a change in my quality of service, then we're going to set up something called a dedicated bearer. Now, I want you to notice how the colors are laid out in this. What I'm trying to represent here is I'm trying to say, when I establish this bearer here, that the second bearer, that is, or what's called a dedicated EPS bearer 1, this is really linked to kind of a subset of, a component of, associated with the default bearer. So in other words, we're going to share an IP address. But we have a different quality of service. So that is the big deal. Default bearer is the first connection to an external network. Dedicated bearers come and go based off of service demands. IP addresses are based off of the default. Dedicated are going to share IP addresses. Very important concepts. I want to go ahead and open things up for questions at this point. And it's possible that you guys just get this, right? I mean, it's very possible that this is, I'm making this thing seem bigger than it is, and to some degree, I'm trying to just kind of overemphasize the differences because my experience has been this default dedicated distinction is very easy to get muddy, and it makes it, as we start to walk through some of the signaling, it makes it more difficult to understand what's really going on. That's one of the reasons I want to try to clarify it. Got a question from David. Why do you show 2 default bearers and 2 P gateways? It's a very good question, David. A P gateway is a connector to the outside world. And for the sake of argument, the second connection just happens to be on a different P gateway. And what I'm trying to show is the level of flexibility that we have here. When my default bearers are established, a different P gateway could be selected. It doesn't have to be that way. It could be that way. So I'm just kind of trying to show that flexibility. Okay, good question. Other questions? Oh, William's got a question. Please tell us the different events when you turn the UE and try to connect to the internet. Different types of events. I'm not sure I follow the question, William. Please tell us the different events when you turn the UE on and try to connect to the internet. Do you mean attach and a default bearer setup? Because that's probably what it's going to be in the sequence of events. Well, that's really what I'm trying to show on this slide. And we're going to walk through some of the details here, William, where it's really going to be connect to the external network, or locate the frequencies and connect, and attach. As part of the attach, we're going to actually authenticate the mobile, and then we're going to set up this default bearer. And then if I wanted to add something after that default bearer is established, I could send data at that point. Is that kind of what you're getting at, William? Okay. Okay. How would you describe always on? Is this a state of the UE? That's a really good question. No, it's really not a state of the UE. What we're trying to say is, for this default bearer, the mobile will always keep its IP address. So even if I even if I go idle, I still have my IP address, and so therefore I'm going to be able to allow other devices to contact me via that IP address. So we just refer to that as always on, saying that doesn't go away. I will always have that IP address, so therefore I will always be able to receive an email, receive an instant message, receive an incoming Skype call, what have you. So the mobile could be connected, it could be idle, but I'll always be able to maintain that IP address while I'm attached. Gabby, do you have a question? I see your hands raised, and so if you want to jump on the bridge, you're more than welcome to.
Can you hear me?
Yes, I can hear you.
I'm sorry, I was slow in typing. The two default bearers, we have the same IP address, correct?
They do not. Each default bearer would have their own IP address.
Okay.
And the reason for that is they want to give that level of flexibility, saying this network at the top, it could use one IP address range. This network at the bottom could use a different IP address range. They're completely separate. So one could be, for example, internet, and the other could be a private corporate network.
Okay. So if I establish one default bearer, I want to connect to APN 1, and then I can connect to APN 2, I'll request another IP address?
Request another default bearer, and yes, you would get another IP address.
Okay, thank you.
That's it exactly. Perfect. Thank you. Question from Robbie. If I connected to two different APNs, would the UE have two IP addresses? Per your drawing, there would be two default bearers, and IP addresses are linked. Absolutely, Robbie, you're correct. If I have two default bearers to two different APNs, which is what I would have, I will have two different IP addresses. Now, this is something that is a little strange if you compare that to the way we do things in 1X EBDO. 1X EBDO, we don't really have this same type of concept of this multiple bearer thing. Even if we want to equate this back to 3G UMTS, this would be like having two primary PDP contacts, which we can do. We can do it. We can't do something like that in DO. What they'll do is they'll have other ways of connecting. But it's this gives me a little bit more flexibility than what DO supports today, but it's not drastically different in concept. Other questions on default and dedicated bearers? William has a question. How many IP addresses will you be allocated for a connection to different APNs? Each APN will give you one, William. Each APN will give you a single IP address. Now, so there are some kind of variability to that. And let me go ahead and open that conversation up right now, just for the because this is probably the best time to discuss it. Here, let's try and jump over to the whiteboard for a second. There's actually three options when I request a bearer. When I request for a default bearer, the mobile will actually request one of three flavors of IP address. We can make a request for IPv4, we can make a request for IPv6, which those are the two obvious ones. And LTE does support IPv4 and it does support IPv6. The third option, which is the one that's kind of squirrely, it's called an IPv4 v6, and this is actually something called dual stack. Now, this is the most flexible. This is the one that I see the most in the logs that I've had an opportunity to look at, is this dual stack. Now, really what this is asking, or what this is requesting for two IP addresses. It's saying, give me an IPv4 and an IPv6 address both. And that way, depending on the type of network I need to talk to, I, the mobile, can use the IP address that is most appropriate. So in this example, I might actually receive two IP addresses. I might receive one v4 and one v6. And so when we look at the total number of IP addresses that we get, we really get one IP address per APN, but we have kind of as a caveat that one IP address could be both v4 and v6, the opposite of what I wrote, both v6 and v4. So that's, I don't know if that's what you're getting at, William, but that's kind of the best way that I can think about answering the question.
Can you hear me?
Yes, I can hear you.
Yeah, I want to know is, when you turn on the UE, then you are allocated a dedicated bearer. Well, what's that called?
Default bearer.
Bearer.
Yes.
Default bearer.
Yes.
And then you get assigned an IP address.
Correct.
And then now, when will you get the dedicated bearer?
Very, very good question. And the simplest answer I can give is when a specific service that requires a different quality of service is initiated. That is the easiest way to think about this. Let me jump back over to my whiteboard for a second. And this is the best example I can come up with it. And it's an IMS example, and I don't want you to take away that what I'm wanting to promote is IMS as being the best solution. IMS has got some challenges, but here's the best visual that I could come up with. We're going to set up a default bearer for the sake of connecting to the IMS network. Now, this is going to be used for my IMS signaling. Now, let's talk about that for a second. What are some of the characteristics associated with IMS signaling? Well, it's not really delay sensitive, in the sense of I could have 100, 200, 300 millisecond delay of a signaling message and it not really do any harm. It's a low bandwidth requirement. But it needs to be always on. In other words, if I power up my phone right now, it may not be for an hour, 2 hours, 6 hours, a day, a week before someone tries to give me a phone call, a VoIP call. Compare and contrast a dedicated bearer. And let's say that what we want for this dedicated bearer is our VoIP call. Okay? So this is delay sensitive. This now needs more of a medium bandwidth. And lastly, the duration is only, we'll say, 3 minutes. Right? If you, again, you look at or whatever the duration of the call is. You look at a standard phone call today, it lasts on the order of about 3 minutes on average. So what will happen is we'll establish this default bearer, and we'll say for the sake of argument at attach, and then we'll establish this dedicated bearer as needed. In this example, I only have one IP address, but I have two quality of service. So does that make sense? That's the best visual I've been able to come up with respect to why they do what they've done with, with defaults and dedicated bearers. Another question. But when a UE is downloading, uploading, it actually needs two IP addresses. Not really. One IP address, it'll be the same IP address for downloading and uploading. Just it's going to be the source address when I'm downloading, and or it's the source address when I'm uploading, and it's the destination address when I'm downloading. So I really only have one IP address. Could you go to a different APN from the same P gateway? In that case, you would keep the same IP address. What determines when an APN will be served by a different PDN? Rasika, it's a very, very good question. So let me kind of break this apart. Could I go to a different APN from the same P gateway? Absolutely. I could have a situation where I've got a P gateway, and I'm connecting to it APN 1, and I'm going to it APN 2. That's actually the most common case, to be perfectly honest. In that case, will it keep the same IP address? No, it will not. What will happen is when we set up that first default bearer, we'll have an IP address. When we set up that second default bearer, we'll have a different IP address. See, the mobile doesn't really understand this whole concept of multiple P gateways. He really only understands APNs. And so therefore, every default will result in a IP address being allocated. What determines when an APN will be served by a different PDN? Completely up to the operator. It could be that I've partitioned my APNs to different P gateways. It could be a load balancing scenario. It's completely up to configuration. It's completely up to configuration. Dan has a question. During the dedicated bearer establishment process, will the UE specify the quality of service requirements, such as with QCI, or use the PCEF MME make decision on what kind of dedicated bearer to set up? Very, very good question. And the answer to that is going to be it's going to depend on a couple of scenarios, and I'm not going to delve into this too much today. Just for the sake of time, I want to leave that for the PCC discussion later in the week. But a dedicated bearer kind of do it in compare and contrast with the default bearer. Default bearers are always initiated by the UE. The network never comes on and says, oh, this guy needs a default bearer, I'll set it up. It's always the mobile initiating. Dedicated bearer can be initiated by the UE or the network. And when we say network, we really mean PCRF. So yeah, both of those are possible. Both of those are possible, and I'll leave further discussion on that, but we'll initiate this to the PCC discussion later in the week. I think, so you need, so why do you need 2 IP addresses when the UE is active? The only time I would need 2 IP addresses if I'm connecting to the 2 different APNs. Now this is a little bit more of a contentious discussion. The way the standard is established, the way the standard is written, is it says you need an IP address per APN, period. That's the way the standard reads. Now, I was having a conversation with a group of people a few weeks ago, and they were really hung up on this. They really didn't like this approach. And so what they were wanting to say, well, why can't I have my P gateway connect to some type of internal IP network, and that internal IP network may connect to various other networks, but that just means I have one default, which means one IP address, and we just configure this network here to do the routing to support multiple connections. So I mean, they really felt strongly about that. And the answer to the question is, you could do it this way if you want. LTE is not forcing multiple default bearers. What LTE is forcing, or not, I wouldn't say forcing, what LTE is promoting is flexibility. And so if you want to set it up this way, where this is network 1, network 2, and network 3, and you have a single IP address, and you are using, and that IP address is valid in those networks, or you're using NATs, or whatever you want to do, but you stick with a single default bearer, that's completely up to you. Can you give a concrete example of when there would be 2 APNs connected to the UE? Sure. Very, very good question. There's probably 2 examples that I can give. One example, which is more of, I'll call it a consumer example, and then another I'll call it more of a corporate example. The consumer example is the internet plus some type of network like IMS or some type of operator value added network. You know, visual voicemail, for example. So I, as a mobile, will have one IP address and one connection to the internet for all my generic internet applications, and a second one to internal operator networks for the sake of, you know, this could be for VoIP versus visual voicemail or whatever. So that's an example. Another example I could use is I could say, well, I'm going to connect to the internet, and then I'm going to connect to a private corporate network. Now, I've said this a couple of times, and let me talk about that, what I mean by this. Let's say we use an example of, I'll use FedEx. And what FedEx has chosen to do is they've chosen to have their employees, especially the delivery people, have a specific network that they connect for the sake of verifying delivery. So what they want to do is they want to have a direct connection into the operator's network. So we go back to this slide here. I might have, we'll go and we'll do it. I might have a direct connection to FedEx. and that is only for people who are employees of FedEx, who've subscribed to the FedEx APN, which me being just a general consumer would never get access to. And so it's another layer of security. Those are the examples that I could come up with. So a question from Dan. I'm going to answer, I've got two questions up here. I'm going to answer these, and we're going to sneak in our last break of the day. During the dedicated bearer establishment process, will the UE specify the quality of service requirement, such as, oh no, I answered that one already. It could be the UE or it could be the network. When UE has two IP addresses, how does idle work? It's going to work in the exact same way. Both of those default bearers are going to stay alive, so that if I receive an IP packet on either of them, I'll be paged. So I meant if there is no traffic on one of the bearers, but there's traffic on the other, okay, in that case, what's the UE state? Good question. A mobile is either idle or connected. So the state diagram is very simple. I'm either idle or I'm connected. So in other words, if I am sending or receiving data on any bearer, I'm connected. Here, no data. And then I have one more question. The last question, we're going to sneak in a break. Once a UE is powered on and attaches to the network and a default and then a dedicated is established, then under what circumstances are the following broken and need to be reestablished? RRC, attach, dedicated bearer, service connection. Also, what is the order in which other connections may need to be reestablished once these are broken? If RRC is broken under some conditions, then after a new RRC connection is established, then would it require establishing a new attach, a new dedicated bearer, a new service connection? Similarly, if a detach happens and then the UE attaches again, then would it require establishing a dedicated bearer? Wow, that is a fantastic question. I'm going to defer the answer to that question until after we take a break, but I will come back, Khurram, and answer that question. And I have to say that and this is probably an old reference that people may not be aware of, but if you've ever seen the movie Back to School with Rodney Dangerfield back in the mid-'80s, there was this one professor who came up and said, I just have one question for you with 17 parts. And Khurram, that's kind of the way I feel with your one question here. It's a great question. We're going to sneak in a 10-minute break, and after we've done the break, I'm going to respond to this question. So I will talk to you guys. We ended on a question before we took a break, but what I want to do is I want to go back in here for a second and make sure everything is working okay. I haven't done anything like leave my phone muted or anything weird. So if you can do me a favor and just any color you want, if you could change the feedback to just anything to let me know that you hear me, purple or whatever, I'll pick red. I like red. Red's my favorite color. Okay, I got some reds and some purple. Yeah, just don't change it from green to green. That's really my only request, because that doesn't really help a whole lot. Okay. All right, good. We've got a good quorum of people. When we kind of broke, Khurram asked a question that was fairly multifaceted. And what I want to do is I want to kind of tackle the question And instead of going kind of line by line through his question, I think I've captured the spirit of it, and I want to kind of draw a couple of pictures, and I think that'll help. So let me draw two pictures real quick. Let me draw a picture of just kind of the, bearer, and then I'm going to talk a little bit about idle and connected. If a mobile has an EPS bearer, the EPS bearer is really made up of three components. So my bearer, which I can draw kind of like this, is made up of this radio bearer, a S1 bearer, which is really nothing more than a GTP tunnel, an S5 bearer, which is nothing more than a GTP tunnel. So I have these resources allocated. And really when I talk about resources, the thing I care about are these radio resources. They're the biggie that I'm worried about. So this is a picture I could say is my connected. If I go idle, what does the picture look like? Well, it's going to look more like this. Now, I'm still going to say that I have a default bearer. I still have a bearer established, but when I'm idle, I only maintain that S5 bearer. So my P gateway still has an IP address allocated for me, but I don't have resources established. I don't have the S1 bearer resources, and I don't have the radio bearer, the air interface resources. So I can go back and forth between connected and idle all the time, and I don't have to reestablish bearers. Now, there was a term that was used in the question for a RRC connection, and that RRC connection is also kind of a term we would use for this bearer here on the left over the air interface. So yeah, I would have to reestablish the RRC connection. I would have to reestablish this GTP connection once I go from idle to connected. I don't have to reestablish the bearer. I don't have to reattach. I don't have to do any of those sorts of things. So really, these two bearers here, this bearer and this bearer, will come and go as needed. Question? Now, let me look at Kuram's question again and make sure that I've captured it sufficiently. So I will have to when a UE goes idle, he will have to reestablish the RRC, but not any of the other bearers. If I power off and power on again, I got to reestablish everything. Reestablish everything. I think I've captured the biggies. Kuram, if there's anything else specifically I haven't addressed in your question, please jump on the bridge or jump back in the Q&A. Crosby has a question. When a UE attached in an idle state, how many sessions will it have? It seems like you mentioned only one default bearer, but in our data dump there is one default bearer and one dedicated bearer session. Please confirm. Good question. So some default bearers can stay up. Or I'm sorry, let me restate that. Some dedicated bearers can stay up when I go idle. Others cannot. Let me give you an example. If I'm dealing with a dedicated bearer that's for VoIP, obviously we can't allow the mobile to go idle because that would be killing the call, right? We would actually have to tear down that dedicated bearer when we go idle. It just doesn't make sense. Logically, it doesn't make any sense. If I'm dealing with something like a dedicated bearer that's used for best effort internet, is used for FTP, is used for uploading or downloading pictures, that bearer can be maintained once I go idle because it doesn't have any quality of service that we're kind of breaking, if that makes any sense. So I don't want to give you the impression that when I go idle, I only have one default bearer. I could have multiple default bearers. I could also have some dedicated bearers. But the point is not all situations make sense. The VoIP is the best example. So good discussion, guys, with respect to dedicated and default bearers. Good discussion with respect to kind of number of bearers and IP addresses and those sorts of things. What I think I want to do at this point is I think I want to move forward, unless there's any additional questions, because I want to make sure we can get through the material that we have in about we probably have about 45 minutes at most before we need to wrap things up for today. So just to kind of take a step back, where we were when we started this default dedicated bearer discussion, we were in the process of looking at the attach. And as we looked at the attach, we were saying that we're going to start with an attach request. We were going to do some signaling. We were going to do authentication security. We were going to select P gateways and S gateways, and then we were going to establish that default bearer. So moving up to authentication, we'll see that attach request come in. The MME is then going to request authentication data from the HSS, and we're going to use that authentication data to actually authenticate the mobile. And that's what's happening here. So the HSS provides this information that we use to authenticate the mobile. Now, actually, two things are going to happen as part of this. One, we're going to authenticate the mobile, but two, we're also going to derive some additional keys that we need. And so the term that's used for this process is AKA, which is authentication and key agreement. Authentication and key agreement, which is really saying nothing more than we've authenticated the mobile and he's gotten keys that we're going to use for ciphering. Now, the way that keys are generated has changed a bit from what we were dealing with in UMTS. What happens is we actually send the MME something called a KASME, a Access Stratum Management Entity. And what this really is this is kind of a key generation key. And with this key generation key, what we're going to do is we're going to actually initiate setting up other keys that are used for encryption. And that's really the key message with respect to this. On top of that, the way we're going to do security is slightly different. We're going to have security between the mobile and the MME for the sake of signaling messages, and then we're going to have security set up between the mobile and the eNode B for both signaling messages and user data. So that's another change from what we saw in previous technologies. Now, one of the terms that you're going to see coming up off and on is integrity protection versus encryption. Integrity protection is really more verify, no change to message, and encryption is more hide. Well, let's go ahead and do this poll and kind of see if this stuff has made sense over the last few slides. This is focusing more on the attach procedure. And so, which nodes have security keys for integrity protection and ciphering upon successful attach insert security mode completion? The MME, the UE, the eNode B, which ones have the keys? Okay, we've got about 35 of our 70 people who've given their vote. I'd like to see if we can get up a bit higher. I want to give everybody a chance to vote. $31, $40, about 40 or so people. We've got two answers that seem to be kind of neck and neck. So remember, question is about after the procedure is completed, which nodes have these keys? So just another 30 seconds, and then we're going to go ahead and discuss. Okay, let's go ahead and discuss the answer. The answer I was really going for was the red one, the first answer, UE, eNode B, and MME. Because that's really that procedure we've just been looking at. Now, those of you who put the middle answer, yellow, as your answer, UE and HSS, truth of the matter is if this was a test, I couldn't knock that. I couldn't really completely mark that as wrong, because you're right, the UE for sure has the keys. The HSS was the one that generated the keys, so therefore both of those I can't argue with. But really the point I want you to see is through this authentication and key authentication and key agreement, aka the mobile, the eNode B, and the MME are all on the same page with respect to keys. That's the dominant story I want you to see. So really, if you marked most of them, then you're going to at least have gotten, part of what I'm going after. The one thing I do want to note, P gateways do not understand these keys at all. So P gateways are not involved in this security authentication stuff with respect to the mobile. So let's look at establishing a default bearer. So the enemy has received the attach, and the enemy is now going to send to the S gateway and then indirectly to the P gateway some signaling messages that are going to establish this attach. And that's what you see on the screen here. So we're going to send a message, and this is a GTP version 2 C message called create session request. Now I want you to see some key information that's in here. We're going to include APNs. We're going to include something called a PDN type, which is really nothing more than this IP v4, v6, or v4, v6 stuff that we talked about briefly. What type of IP address do I want? The S gateway is going to forward that to the P gateway, and then we're going to get a create session response, and at this point we will have a tunnel established here, and you can think of towards the E node B, kind of half a tunnel is established. So in other words, the S gateway knows what's going on, but the P gateway, or I'm sorry, the S gateway knows what's going on with respect to this tunnel, but the E node B does not. He doesn't learn about this stuff until the next step. Create session request going to the P gateway. We've already looked at this briefly. In this response message is where that IP address is going to come, in this create session response. So that's how the mobile will receive his IP address. We're then going to turn around and send this to the E node B so it can establish the radio connection over the air. And that's what we're seeing on this slide. One too many. We've got this attach accept, and that attach accept is being pushed down to the mobile. And then the last thing we have is an actual modifying the bearers, basically turning them on. You can imagine up prior to this step, we had established the bearers, but we hadn't actually turned the bearers on. Okay. So the key message I want you to see here is attach and dedicated, I'm sorry, I gotta say it correctly, attach and default bearers are established at the same time. I don't even like the way I said that. Attach an A default bearer, a single default bearer, not multiple. Okay, a couple of quick polls. The P gateway always initiates default bearer setup. True or false? At 70 people, we need to have at least 50 voting. I want everybody to at least think about it. And really, I would much rather you put the wrong answer so that we can talk about it and make sure it's clear than not vote. Okay, so 34. It's actually neck and neck. That's pretty cool. It looks like the political election process here in the United States. Oh, the Reds are starting to take the lead a little bit. The P gateway always initiates default bearer setup. Oh, the Reds are dominating. 49 votes. Can I show the voting? Oh, I didn't realize the votes weren't. No, the votes are shown. Yeah, they're there because I can see them on my second computer that is there. So yes, they are being shown. I can hide them. 50 people. No more votes? Going once? Going twice? Oh, the minority is actually the one that's correct. What we're trying to say here is the P gateway doesn't initiate default bearer setup. It's actually the mobile. It's actually the mobile that initiates it. And I agree, the wording towards a default APN, I can see if that kind of twisted a little bit, but really what I want you to walk away with this is the mobile always initiates default bearers. The network never does. So the answer is false. I didn't talk about tunnel endpoint ID, so I'll let you kind of look at this and you can start thinking about the answer while I talk. The question is, this is the total number of tunnel endpoint IDs for a given bearer that would be used to send, receive IP packets to and from a P gateway. And so the thing I want to talk about with respect to tunnel endpoint IDs is for every tunnel, each side needs a tunnel endpoint ID. So, for example, if I was dealing with you know, having multiple tunnels, it's not just a tunnel endpoint ID per tunnel, it's a tunnel endpoint ID per end of tunnel. So, it's kind of an interesting race here. I've got some voting 2 and some voting 4. Now, there's a 1 and a none of the above. The total number of GTP tunnel endpoint IDs for a given bearer, defaults are dedicated, that would be used to send and receive IP packets to and from the P gateway. Oh, and I see, okay. Yeah, this is going to be an interesting discussion. Let's see, we're up to 20, 30, 40, 44. Let's get another few people in and then we'll move forward. I got one more discussion. Actually, a couple of little short discussions I want to have before we wrap things up here in a little bit. The answer I was going for was 2. But before anybody changes their vote, let's talk about this for a second. So let's kind of go this approach. It's not none of the above. I didn't, you know, it's not none of the above. Is it an odd number? Is it 1 or 3? No, it's not going to be an odd number because each tunnel needs 2 endpoint IDs. So it's got to be an even number. So now we're down to 2 or 4. Now, my thought was 2 because a tunnel needs 2. But those of you who put in 4, were you thinking, well, I have 2 tunnels. I've got one tunnel on the S1 interface and one tunnel on the S5 interface. So 2 tunnels, each tunnel requiring 2 endpoint IDs. So therefore, I am up to needing 4 tunnels. And if that was your logic, I have a hard time arguing with that one. As a matter of fact, I think I would have answered it 2, and I think I would be thinking the other way. And Mike's come on and said I was thinking 2 tunnels, which requires 4 tunnel endpoint IDs. So yeah, so that's a good point, right? I mean, I can't argue that logic. So if you put 2, I think you're getting the key message. If you're putting 4, you get bonus points. They don't help in any way, but you get bonus points. Okay, fantastic. Basically what this next set of slides is creating a second default bearer. And so this is a terminology that I wish they would have not made it so cumbersome. And so basically they use the term default twice. They use one form of default by saying we've got this default APN, I'm sorry, default bearer, and really the simple definition of what a default bearer is the first bearer to an APN. That's what we've been talking about. Well, there's a second terminology that they use in the specification, which is a default APN. And what I mean by a default APN is this. It is the first default bearer and this is to, I'm going to kind of draw it slightly different, this is to a specific APN. And so the other point that's kind of important here is this is always done during the attach procedure. So in other words, the APN that I'm connecting to for that default bearer during the attach is called the default APN. All other default bearers will do in a separate way, and that's what these next couple of slides represent. And I apologize. The term default is really kind of squirrely, the way they're using it here. I wish they would have come up with slightly different terms. So in this example, we already have a default bearer established, but we now want to connect a second default bearer. So I have one to IMS, and I now want to connect one to the Internet, for example. So we're going to do a PDN connectivity request. That's the message name. That's going to pass up to the MME. It's going to be sent, and then it's going to pass up to the MME. The MME is going to verify that that's an okay thing, and then he's going to pass it up via the S gateway to the P gateway. Now in here we're going to have all of the appropriate quality of service stuff. We're going to have which APN we're connected to and quality of service and IP address type and all that kind of jazz. The P gateway is going to respond, and in here we're going to include that IP address like we've already discussed. We're going to respond to the MME. The MME is going to send information to the eNode B, which forwards it down to the mobile. And then we have our acknowledgments. And at this stage of the game, a mobile has two default bearers established to do two different APNs. I want to stress one point. Having multiple default bearers is completely an optional thing. It's depending on how the operator wants to set up their network. I am expecting us to do it, but that doesn't mean it's a requirement. And that's just kind of what I want to make sure is clear. I'm going to go ahead and open up this poll, and we'll talk about this, but if anyone has questions, please feel free to throw those into the Q&A while we're taking this poll. What do the bearers look like to the transport network? The routers between the eNode B, S gateway, P gateway on the user plane. How are the parameters set for each dedicated or default bearer maintained? Rasika, I hope I'm pronouncing your name right. That's a very, very good question. And the answer is going to be, unfortunately, proprietary. The standards do not talk about how things map to the transport network per se. But it's going to be based off these quality of service parameters. So, for example, if I'm using MPLS, we're going to use MPLS-specific descriptions between the IP layer and the MPLS layer to communicate this. And that will be built into the P gateway and the S gateway. So other than primitives or procedure calls between the IP layer and the transport network layer, I can't really comment much more. Thank you. Good question. So you may create a default EPS bearer towards a non-default APN only while roaming. Yeah, pretty straightforward question. The answer is false, as a lion's share of people have. We always have that default APN. My second whole question, if Kathy has subscribed to 2 APNs, Internet and IMS, and has established connectivity with the relevant PDNs, which statement would be most accurate? She'll have 1 default and 1 dedicated. She'll have only 1 default. She'll have 2 defaults and potentially some dedicateds. She will have 2 dedicated bearers. Yeah, I want to give you some time to answer this one, because this is really trying to make sure that we're clear on what is the difference between a default and a dedicated bearer. So one of my colleagues came up with this question, and it is a good question to make sure this stuff is clear. This is not one like some of the other questions we've had. This one isn't going to have multiple correct answers. There's really only one answer that is correct based off of everything we've discussed. And I want to also make sure that I'm clear, that last kind of phrase, which, if Kathy has subscribed to 2 APNs and has established connectivity with the relevant PDNs, what that's really saying is it's saying, I have a connection to both APNs, right? I want to make sure that we're clear. This isn't a single bearer thing. I have at least 2 bearers. What are they? Up to 42 people. So I think we're probably have a good quorum that have voted. I'd like to see everybody vote. 43, 46. So as the majority has stated, it is the yellow. Yellow is correct answer. I'll have 2 defaults. Let's talk about each of these answers as we just make sure why they're clear. Why is yellow correct? Well, let's talk with the blue. Blue had the least number of votes. Well, it can't be blue just because I only have 1 bearer total. And as I've said, I'll have at least 2 bearers, 1 bearer for Internet and 1 bearer for IMS. Let's drop down to green. It's not too dedicated because my initial bearer to any APN is always a default. So I got to have defaults floating around in here. So really the question is it the red or the yellow? And I go back to that basic definition of a default bearer. It's the first bearer to an APN. So if I have 2 APNs, at a minimum, I have to have 2 default bearers. And that's what the yellow answer is really talking about. So it is yellow. But before we move on, I want to make sure that that makes sense, because that is such a critical part of LTE. It is worth spending a little bit of time to make sure that that is, that you understand why I'm saying that. Questions about the answers to this question, specifically the yellow being the correct one? Okay, good. Really important, really, really important. All right, we have really one topic left, and this isn't a very big topic. We're going to go ahead and kind of deal with establishing a dedicated bearer and releasing a dedicated bearer. look at a couple more signaling, and then we're going to wrap things up for today. So what we have is we have a default bearer set up. So a default bearer is set up. Well, we can call that step 0. So step 0 is a default bearer. And I'm going to kind of draw that in here. Oops, not where I want it. I'm going to draw it to here. I've got a default bearer established. In step 1, I'm doing signaling. Now jump in the Q&A. Help me out here. From the S gateway's perspective and the P gateway's perspective, from LTE's perspective, how would you describe what it thinks, what LTE thinks this signaling is in step 1? Any thoughts on that? What does LTE think is going on in step 1? You can just type something in the Q&A, and I'll read what people write in there. Bill says, just tunnel IDs. Excellent. Excellent answer. What's another way you guys can answer this question? What does LTE think it's doing in step 1? Mike has initial attach and permitted to contact the network. So yeah, we have the default bearer established through the attach. And maybe my question's a little bit too abstract. Okay, let's see, Ravi is setting up dedicated bearer. No, step 1 isn't really setting up a dedicated bearer. Because that result we're going to, man, I've just lost the ability to speak. That's what we're going to do in step 2 and 3. I think David has it. I can kind of see the answer. Passing bearer traffic to the APN. Exactly, David. That's exactly what I mean. Step 1, LTE thinks it's just delivering IP packets. It has no idea of the contents. No idea to the contents. A couple people are putting setting up signaling link in step 1. No, it's really just delivering IP packets. Gabby, do you want to jump in with a question? Okay, jump in there if you have one. But step 1 is really the mobile having a conversation with this, in this example, an IMS network. We could take this question kind of abstract it a little bit. We start talking about if I, the mobile, am having a conversation with an instant messaging server, with a web server, with a content server in the internet, what does LTE think it's delivering? IP packets. It doesn't understand these things. It has no clue, nor does it care, by the way. So in step 1, we're doing IP packet delivery. But because we're talking to an IMS network, the IMS network pushes a session modification message to the P gateway. So this is actually the IMS network initiating this. Now, IPCAN, that is a generic term that means IP Connectivity Access Network. Basically, in the context of what we're talking about here, it means LTE. So the P gateway is going to receive that message, and he's going to say, we need to do something. We need to establish a dedicated bearer. And that's step 2, is the initiation of that dedicated bearer. Step 3 is dealing with radio resources, and then step 4 is basically the acknowledgments for setting up this dedicated bearer. So this is an example of a network initiated. It could also come from the mobile itself, but we're looking at a network initiated. So we had that push from IMS. That's what I'm representing by the arrow, by the P gateway in the upper right-hand corner. The P gateway will send out a create bearer request. Now, there's really only one parameter that I want you to see and hear. This is the one that I think is interesting to kind of help explain the concepts that we've been talking about. And that is this first parameter here at the top. It's a linked bearer ID. What this linked bearer ID is really saying is it's saying which default am I linked to? So which default am I sharing an IP address of? Which default is really doing signaling associated with this one, what have you? That gets pushed to the S gateway and then to the MME. I don't show the S gateway to MME push. The MME will then send a message to the E node B saying we're wanting to establish a radio connection for the sake of this new bearer. And then we'll include that new bearer information in here as well. That will result in radio resources being established over the air. And then we get some acknowledgments. So what's happening here, gang, is we really are having we had a GTP tunnel for the default. We're now establishing a GTP tunnel here for the dedicated. We had a GTP tunnel to the S gateway for the default. And now we're establishing a second one for the dedicated. We tell the mobile, so the mobile can have the appropriate radio resources established, and that's in this slide. And then we have all of our acknowledgments. So we have an acknowledgment from the mobile that this was set up. We have an acknowledgment between the E node B and the MME, and then we have an acknowledgment to the P gateway saying the bearers are established. So that's establishing a dedicated bearer. Now, as I said, this is assuming it's a network initiated. There is an option to have the mobile initiated as well, and there will be slightly different signaling, but not significantly different signaling. So questions about establishing a dedicated bearer. What sort of type of traffic goes on the default bearer? Very good question. For this example, this would be my IMS signaling IP packets. So it would be things like registering an invite message. If you're familiar with SIP at all, it's messages like invite, register, message, those sorts of things. So default could be anything. Could be internet traffic. It could be what have you. In this example, it's these SIP signaling messages. Whereas the dedicated bearer would be the VoIP traffic. Does that make sense? Okay. Our last topic. So we established a voice call, a voice over IP call. The call ends. So now the IMS network sends a message into the P gateway, modifying the session again, basically saying this bearer that you set up doesn't need to exist anymore. P gateway sends a delete bearer request. That gets mapped into a releasing of the radio resources. We reconfigure the connection down to the mobile. And then we get a bunch of glorified acknowledgments. And at this stage of the game, that bearer, that dedicated bearer that we established for the sake of VoIP traffic, is now released. Let me ask you a question based off of everything we've talked about. True or false? Dedicated bearers can time out due to their being idle. Oh, the blues are starting to catch up. The reds kind of had a run there for a minute, but the blues are catching up. Oh, we're up to, what, 42 votes. Red slightly in the lead. Oh, still a little red. Question while this is going on. If the default was to an APN such as the Internet and the dedicated bearer was set up to another APN. Okay, so let me be clear, Rosika. Let me just kind of look at your first kind of phrase in your sentence. If the default bearer was to an APN such as the Internet and the dedicated bearer was set up to another APN, that's not the way it works. We always set up a default bearer to an APN first. So I would have a default to the Internet and I would have another default to the IMS network. Then we could generate a new dedicated bearer. Okay, so that's the first thing that I want to make sure is clear. So the rest of your question with respect to getting a new IP address, right? That once we get the foundational definitions of default and dedicated, we see that IP addresses are only associated with defaults. Can we have different dedicated bearers for the same application on the Internet? Example, online gaming, YouTube video, those sorts of things. Ravesh, very, very good question. Technically, the answer to that question would be yes. But probably not in practice, since the Internet is just a general purpose network, and we're probably not going to do differentiated qualities of service for the Internet. The main reason is just because of cost. So think about this for a second. Which is cheaper for an operator to implement? Best effort, which can only go on a default bearer, or differentiated qualities of service. Well, obviously it's the default. And so in the Internet, unless there's some type of tariffing model set up to facilitate that, it's probably not going to be, we're probably not going to do dedicated bearers. But in your example, we could. LTE would support it. All right, let's look at the vote. The vote is now a lion's share, 2-to-1, true over false. If we're dealing with a dedicated bearer, like what we have for IMS, or I'm sorry, for VoIP, absolutely, a bearer can time out. A bearer can time out. There are certain dedicated bearers which might not time out. So those of you who answered true, that's really the right answer. But those of you who answered false, I agree with you, it depends on the circumstance. Depends on what we're doing. And most of the bearers that we're going to be dealing with early on, best effort bearers, I don't think they're going to time out. I really don't. All right, good. Okay, excellent, guys. So what we've talked about today is we talked about the big 4 nodes in the EPC: MMA, HSS, S-Gateway, and P-Gateway. We've talked about the main protocols and the main interfaces. We looked at the essential steps of an attach, and we also looked at the essential steps of doing both dedicated and default bearer establishment. And the other thing that we talked about is the difference between a dedicated and a default bearer. And as I said, really, if there's nothing else that you get today, I really want you to get that distinction between dedicated and default bearers. It's amazing how important that is for the rest of the discussion on LTE. Let me open things up for questions. Well, here's what I want to do. I'm going to throw things over to Brenda so that she can put up the evaluation. And while the evaluation's going on, if anybody has questions, I can verbally answer them, but I can't touch anything.
Okay, Chris. I'd like to, again, thank everyone for joining, and, of course, thanking Chris for a great session today. He's going to send us in the Alcatel-Lucent University his whiteboard notes, and we will also have the annotated PowerPoint files, and they will be forwarded to everyone that was on the session today. Right now I'm going to go ahead and display the end of course evaluation. Please make sure that you are in full screen mode, F5, and click on the Proceed button when you have finished the survey. After you finish the survey, please drop off the live meeting bridge and exit out of the live meeting interface as well. Then we'll know how many people still have to complete. We will keep the live meeting survey up for about a half an hour. And if you have any questions or any problems accessing the survey, please IM me or email me at brenda.strubel@alcatellucent.com. So let me go ahead and put that up. And as Chris mentioned, during this time, if Chris will stay on the line and answer any questions you have on the phone bridge. So if you'd like to open up the bridge, please open that up with *7. And we again thank you for taking the time to attend the session, and your evaluation and feedback is really vital. So please go ahead and make sure you fill out the survey when it comes up. Chris, do you see the survey coming up?
I saw the page, but I'm not actually seeing it on mine.
Okay.
But I'm extra. Okay, I see it now. I see it now.
Okay, great.
I do have two questions that have come up on the chat, and they're actually the same question, which is nice. What is the maximum number of bearers? The standard is going to say that the maximum, and there's a couple of places, it's kind of a squirrely thing, but basically it is 8. We can handle 8 bearers. Now, are those default or dedicated is kind of another flavor of question that's popped up. And the answer to that question is yes. I could look at this as bookends. I could have 1 default and 7 dedicated, or I could have 8 defaults if I was connecting to 8 different networks, but the total is only 8.